Hi, my name is Dan, and this video is one in a series of videos about how to do blueprint scripting for Unreal. And in this one, I'm going to be looking at some maths nodes that you can use. So please don't worry. I know that the word maths puts a lot of people off and scares them. Maths, of course, is brilliant, and you can do all sorts of brilliant things with it. But you might not feel the same way that I do about this. I'm a bit of a maths geek at times. Anyway, so the setup that I've got here is I've got a third-person template map. I've got a little blueprint that I've created myself. I've got an instance of the blueprint out there in the world. And inside this blueprint, I've got a pressure plate, which is just there for show, and a collision box, which detects when the player stands on it, and a light, which is currently set to be a red light and is currently switched off, so we can control that through some script. Okay, so let's get into that script. Yes, the other thing that's happening is that I'm automatically detecting when the player stands on the plate and when the player steps off the plate using this variable is on. Okay, so what we're going to do is we're going to try and make it so that the light flashes regularly. But also that it only does it when the player's actually stood on the plate. Now, that condition of standing on the plate isn't too hard. The rest of it is a little bit of maths and maths nodes to make it happen. And again, not too bad and not too complicated. So we're going to start with making sure we've got the tick node, because somehow that's disappeared. And we're going to use the delta seconds, and we're going to have a timer. And if you've been watching along in the other videos in this series, you'll have seen me do this before. So I'm just going to have a timer variable and change that to a floating point. So in fact, you'll have seen most of what I'm going to do in this video before if you've been watching this series of videos. But I just want to emphasize the maths nodes that we're using this time around. So I'm going to get the timer. This is going to be a running timer, and I'm going to use the plus node. So when I type plus in, it gives me a few options here, but the one that we're wanting is float plus float. So that's adding two floating point numbers together. And it gives us 2 pins so that we can put the two different values we want to add together in. I know that this means, because of the way I've dragged it out, that these wires are crossed. That's not important, because addition, as you know, 3 plus 5 is the same as 5 plus 3. It doesn't matter which way around you do them. If it was a takeaway, a minus, that would be important. But in this case, it's not. And so I'm being lazy in not sorting that out, just leaving them across there. And what we're going to do is drag that off again and set that timer variable every time a tick happens. Right. Well, actually, what we want to happen is that we want this to be doing a switching every so often. And maybe we don't know how often that's going to be. So maybe we want that to be different intervals or different speeds of flashing, depending on which instance of the little blueprint we've got. So let's have another variable we're going to call interval. And that's going to be an amount in seconds, which is when it's going to trigger something to happen. And we want to expose this variable so that we can have it different in different instances. And I'm going to quickly compile and set a default value of that variable of 0.5, which I'll do over on the right-hand side there. So what we want to happen is when timer, which is counting the time, gets above that interval, it's going to trigger something, which we can do with using the control flow. But also it needs to reset that timer every time it gets to the interval. So the first thing we're going to do is we're going to check when the timer has become greater than that interval. So I'm just going to create another getter for the timer and drag out from there. And I'm using the the greater than symbol. So this is a comparison rather than an operation. We'll check one float against another float, and we've got greater than or we've got greater than or equal. So with floating point numbers, it really makes no difference which one you use usually in these circumstances, especially with this timer, seeing as it's going every frame, so it's only counting up in very small amounts. So again, out of laziness, I tend to just use greater than. And we're checking whether it's greater than this interval, which is currently set to 0.5, but we can set it to something else. And when that happens, we want something to happen to the timer. We want to chop it back down to 0. So I'm going to do that, which we're going to do using a branch. And actually, just to show you show you another node, instead of just setting the timer to 0, what I'm going to do is I'm going to take the value of interval off the timer. So if we happen to have a great big slowdown and the frames start taking quite a long period of time, this will still be robust, because however further we've gone in time than the interval amount will be retained in the timer variable. So we're going to make a timer, we're going to set up a timer, set timer, so timer needs to be the old value of timer minus the interval, and so minus there, and again we've got some different options here, but the top one, the most common one, is float minus float, and we're going to plug in the interval there. Okay. So now this is this is going to happen just when it gets over past when the timer gets past the amount that the interval is set at. So execution will come out here every time we pass the interval, and is resetting the timer, which is what we want, but also this is where something's going to happen. And what we're actually going to want it to do is to switch the visibility of the light. We're going to make it switch on or off. Actually, before we do that, we want another branch, because that branch is going to be dependent on the is-on variable that we've got. So it's only going to be switching on and off when we're actually stood on there. Okay. And what do we want to do? We want to switch on or off. So this is, it's called logic really rather than maths, but it's within the same kind of field. So we're going to grab that light, which is the point light. We're going to find out whether it's switched on or off. So we're going to do get visibility, get visible, and then we're going to do the Boolean operation not, which inverts it. So if it's true, then the output from this is false. If it's false, the output from this is true. And then we're going to do, once again, use point light, and we're going to set visibility. I'm going to take that value from there. So this is going to toggle the visibility. It's going to switch it on and switch it off. Once we're stood on that plate, and we should be able to change the interval that works at. I've done a whole lot of stuff without testing it, so let's stick it on and test it. Step on the thing, the light's on, off, on. Is that half a second? That seems to be about right. And then we'll step off. One of the effects of this is, if I step off whilst the light's on, it leaves the light on because it stops the switching. Right. What I'm going to do now is just to quickly demonstrate that this thing with the interval is working. I am going to create another instance there, and I'm going to make that one go quite a lot faster at 0.2 seconds interval. So I've changed the variable for 1, that's going at half a second, and that's going quite a lot faster. So that's using maths to arrange that. There are, of course, nodes for just about any maths that you can think of. There's multiplication, obviously division. We've seen adding, we've seen minus taking away. We've seen a greater than, so that's a comparison. We've seen a Boolean not. There is just one more thing that I wanted to show you, which is a special node, which is the math expression node. And if we just, I'm not going to actually use it, I'm just going to show you the node. Math expression. Let's have math expression. It's got the American spelling of math rather than maths. And this has given me a node with a bit of text at the top. and it's at the moment saying unexpected token type. What I need to do is to type in some kind of algebraic formula in here. So if, say I wanted to do the, I'm going to say the quadratic. Well, that's a little bit complicated. Let's not do that. Let's just do A and 2 times B divided by C. I'm going to zoom in a bit so you can see that a bit more closely. So I've just typed a mathematical expression in there with variable names. It doesn't matter what those names are. It should recognize any reasonable letter combination for variable names. And I press enter, and it's read that, and it's worked it out, and it's given me pins for A, B, and C. And I can either use the boxes here to give values, or I'm more likely to be dragging in from some variables, and it performs this formula expression here and will return the value out. And as you see, there's a floating point numbers in here, which is what math expressions use. And it's a way of conflating. You could do the same thing, obviously, with a set of different nodes, adding these things together, doing the multiplication and the adding and whatever you wanted. Epic say that doing a expression node is likely to run a bit faster than doing it using separate nodes. So it's worth using if you want any more complicated maths expressions there and there. Okay, so there are loads and loads more maths nodes that you can get into and play with, and you'll be seeing them in later videos as we go through, but I just wanted to give a quick introduction to some of the basics there. So that is it from me for now.